Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing complex conjugates. So a complex conjugate is not a terrible idea. It is, the only thing it is that if you have a complex number, a plus bi, all you do is you change the number in front, or you change the sign directly in front of the I term to be the opposite sign. So if it's positive, it becomes negative. If it was negative, then it would become positive. So we say these are conjugate to each other. And as it turns out, the reason why we would do this is kind of interesting. It has a very nice simplified multiplication. So if we multiply one conjugate, one number with its conjugate, one complex number, its conjugate, a plus bi, a minus bi. Well, if you multiply things out, a times a was the a squared, a times negative bi is negative abi, and then bi times a is positive bi, and then bi times negative bi is negative b squared I squared. So negative bi and positive bi cancel. And then further, we have the a squared and then minus b squared I squared. Remember that, so we have a squared minus, I squared is negative 1. So we have b squared, so we have basically, instead of b squared, we have negative b squared. So minus negative b squared, and a negative of a negative is positive. So the interesting thing about why you multiply a complex conjugate with a complex number with its complex conjugate is that notice that there's no I here. And in fact, it's very nice. It's being added. Two real numbers being added, so it's positive as long as both of them aren't zero themselves. So we always get a nice real number out when you do this. And it simplifies to this. So just basically the square of each term of each one, the sum of the squares. So let's ask ourselves, what is the complex conjugate of negative 3 minus 7i? Well, it's negative 3 plus 7i. It's the number, it's the change of the sign of the number in between. And what happens when we multiply negative 3 minus 7i with its conjugate, negative 3 plus 7i? Well, we could go through the whole thing like we just did here, but we see that it always becomes a squared plus b squared. So we're asking, what is the a? It's just the number. If you want to include the negative, you can. You don't have to. So if you want to include the negative for this one, you can. You don't have to. It really does not matter, because when you square a negative, it becomes positive. What is negative 3 squared? Well, it's negative 3 times negative 3, which is positive 9. What is negative 7 squared? Well, it's negative 7 times negative 7, so positive squared. So depending on how you look at it, if you included that one, again, it would be fine. So, negative 7 squared is positive 49. And what is 9 plus 49? Well, that's 58. So without going through the full multiplication, which you can do, which we did in part 2, but with the conjugate, you get this really nice simplified result. So what, for number 2, do we have? Well, what is the conjugate? Let's just denote that this is in fact the conjugate. What is negative 2 plus I? Well, negative 2 plus I, the conjugate, is negative 2. And we just changed the sign of the number in front of the I, so minus I. So this is the conjugate. We're going to go through and multiply this complex number with its conjugate. Again, the whole nice thing about this is that we don't have to go through the full multiplication if we don't want to. What is the a? The a is the negative 2. Again, the a does not include the I. It just includes the coefficient in front of the I. So negative 2 squared plus, again, square of one coefficient plus the square of the other. What is the other coefficient? It's the number in front of the 1, or in front of the I, and it's 1. And what is negative 2 squared? It's positive 4. What's 1 squared? It's 1. And 4 plus 1 is 5. That concludes everything from this section.